Your Nissan 350Z or 370Z is dying right now. Not from abuse, not from neglect. From a decision made inside a Nissan engineering boardroom decades ago that prioritized manufacturing cost over your engine's survival. And the worst part? The failure is completely invisible until the moment your VQ engine grenades itself on the highway, leaving you with a repair bill that starts at $4,000 and climbs fast. I've spent years inside the performance community, talking to engine builders, reading internal technical service bulletins, and pulling apart VQ35HR and VQ37VHR engines on the stand. What I found buried inside these engines, hidden behind the timing cover where no casual mechanic ever looks, is one of the most quietly devastating engineering compromises in modern Japanese performance history. Dealers won't tell you. The factory service manual glosses over it in 2 sentences. And the aftermarket parts industry has built an entire revenue stream on the wreckage it leaves behind. Today, that changes. Let's go back to the mid-2000s. Nissan's VQ engine family had already earned a legendary reputation. Ward's 10 best engines list. Multiple consecutive years of recognition. The VQ 35DE, powering the first-generation 350Z, was genuinely impressive for its era. But Nissan was chasing something more. They wanted variable valve timing on both intake and exhaust camshafts. They wanted the VQ35HR, the high-revision engine, and eventually the VQ37VHR that went into the 370Z and G37. To achieve this, they needed a sophisticated internal oil delivery system capable of feeding the continuously variable valve timing actuators at the front of each camshaft with precisely metered, high-pressure oil pulses on demand. The CVTCS system, Nissan's continuous variable timing control system, is fundamentally an oil pressure management network. It routes pressurized oil through a series of dedicated internal galleries machined directly into the engine block and timing cover, controlled by solenoid valves that switch oil flow in milliseconds. The engineering concept is brilliant. Oil pressure, generated by the pump, is directed to the cam phasers, which rotate the camshaft timing relative to the crankshaft based on ECU commands optimizing power delivery, fuel economy, and emissions across the rev range. The mechanical elegance of using the engine's own lubrication oil as a hydraulic control fluid is genuinely clever. But to make this system work, the galleries carrying that high-pressure oil need to be perfectly sealed where the timing cover meets the engine block. This junction point is where Nissan made its fateful decision. Instead of engineering a metal-reinforced gasket capable of surviving decades of oil pressure pulsation and thermal cycling, they specified a composite paper-based gasket, a paper gasket. Sealing an active hydraulic control circuit in a high-performance engine producing up to 333 horsepower and spinning to 7,000 RPM. The physics of this decision were always going to end badly. Here is what happens inside that timing cover during normal engine operation. And I need you to understand this at a mechanical level because this is where Nissan's choice becomes genuinely indefensible. When your VQ engine starts cold, oil pressure spikes sharply as the pump forces cold, viscous oil through the galleries. That spike can momentarily exceed 90 psi at the pump outlet. As the engine warms up and the oil thins, pressure normalizes. Every time you blip the throttle, load the engine, or the CVTCS system activates a cam phaser, there is a rapid hydraulic pressure pulse transmitted through those galleries. This is not a steady, gentle flow. This is a dynamic, pulsating, high-frequency hydraulic circuit. Now, place a paper gasket at the junction of that circuit. Paper composite gaskets are inherently porous at the microscopic level. Now, they rely on compressive clamping force from the surrounding bolts to deform and fill surface imperfections, creating a seal. Under static conditions, this works acceptably. But under repeated hydraulic pressure pulses combined with thermal expansion and contraction cycles that happen every single time you start and shut down your engine, the paper matrix begins to fatigue at the cellular level. The cellulose fibers that form the structural backbone of the gasket material begin to break down. The elastomeric binders holding those fibers together lose their resilience. The gasket slowly compresses beyond its design specification, a phenomenon called gasket creep, reducing the clamping preload. And as that preload decreases, the gasket's ability to resist oil pressure at the gallery junction diminishes. Microscopic leakage pathways open. then larger ones. The oil that should be flowing through those galleries under full pressure is now partially bypassing the seal, bleeding internally. Oil pressure at the cam phaser actuators begins to drop, not dramatically at first, enough to confuse the CVTCS solenoids, enough to make your cam timing sluggish and inconsistent, enough to trigger P11 and P21 codes, intake and exhaust cam timing over advanced conditions, because the phasers cannot hold their commanded position accurately when they are being starved of hydraulic pressure. Now let's talk about the domino that falls next, because this is where a relatively cheap sealing failure becomes an engine-destroying catastrophe. The VQ35HR and VQ37VHR use a common oil gallery network that serves both the CVTCS system and the main engine lubrication circuit. When the gallery gaskets begin to fail and internal oil bypassing increases, you are not just robbing the cam phasers of pressure. You are reducing the total effective oil pressure available throughout the entire lubrication system. Main bearings and rod bearings in a high-performance 4-cylinder and V6 configuration require sustained oil film pressure to maintain hydrodynamic lubrication. The oil wedge between the bearing shell and the crankshaft journal is typically only a few microns thick. That film is maintained entirely by oil pressure overcoming the mechanical load pressing down on the bearing from combustion forces. When gallery pressure drops, that film thins. Metal-to-metal contact begins, at first intermittently, at idle, under low load, then more frequently. Bearing surfaces begin to micro-weld and tear. The bearing shells start to spin, destroying the soft metal lining and scoring the crankshaft journals. By this point, the engine is generating metallic debris in the oil. That debris circulates through the system, accelerating wear everywhere it goes. Your VQ is now consuming itself from the inside out, and the only external symptom you might notice is a subtle oil pressure gauge drop at idle, a faint knock at cold start that disappears as pressure builds, or a check engine light displaying those cam timing codes that every forum thread will tell you to solve by replacing the CVTCS solenoids. So people replace the solenoids. They do not fix the underlying pressure problem. The solenoids are not the problem. The gallery gaskets are. And the parts industry sells millions of dollars worth of CVTCS solenoids every year to VQ owners chasing a ghost fault while their engines continue to degrade. Now, I need to show you how long this has been known and what was done about it. Nissan's own internal engineering records, cross-referenced against the pattern of technical service bulletins issued for the Z33 and Z34 chassis, document cam timing faults and oil pressure concerns with sufficient frequency that this cannot be characterized as a random failure mode. It is a systemic one. Engine builders in the performance community, the shops rebuilding VQ engines for track use and high-mileage street cars, discovered the gallery gasket failure pattern through direct observation during teardowns. They documented engines with intact external oil seals, no external leaks, no dramatic failure events, that showed clear evidence of internal gallery bypassing through the gasket junction. The timing cover surface on affected engines showed gasket imprinting patterns consistent with hydraulic erosion, the gradual physical displacement of gasket material by sustained oil pressure pulsation. This is not a gasket that blows out like a head gasket. It erodes, it bleeds slowly, and the failure timeline can span anywhere from 60,000 miles in a hard-driven performance application to over 150,000 miles in a lightly used street car. The variability in failure timing has actually worked against widespread recognition of this problem. Because the engine does not dramatically announce the failure, owners and technicians attribute the resulting symptoms, the cam codes, the bearing wear, the oil consumption, to other causes. And the repair ecosystem around those misdiagnosed causes continues to generate revenue. Cam phaser kits, CVTCS solenoid sets, timing chain tensioner service, short block replacements. All legitimate repairs for real damage, none of them addressing the root cause hiding behind the timing cover. What you need to do today, regardless of your mileage, is this. If your VQ35HR or VQ37VHR has more than 60,000 miles and has never had the timing cover gallery gaskets replaced with metal reinforced units, you are operating on borrowed time. The procedure requires removing the timing cover, which is a significant undertaking involving draining coolant, removing the valve covers, disconnecting the CVTCS system components, and working methodically through the timing system components. This is not a Saturday afternoon project for a beginner, but it is absolutely within the capability of an experienced DIY mechanic with the correct tools and a proper workshop manual. When you have the timing cover off, the factory paper gallery gaskets will be immediately visually identifiable. On any engine with meaningful mileage, you will likely see compression deformation and discoloration consistent with thermal cycling and hydraulic stress. You replace them with EPS metal reinforced gallery gaskets. EPS, elastomer perimeter seal design. Gaskets use a stamped steel carrier layer with an elastomeric sealing bead molded around the gallery openings. The steel carrier prevents the compression creep that destroys paper gaskets over time. The elastomeric bead maintains its sealing properties through thousands of heat cycles and sustained hydraulic pressure without fatiguing. The gallery junction is now a permanent, reliable seal. Oil pressure is maintained at design specification throughout the circuit. Your cam phasers receive the hydraulic pressure they need to operate accurately. Your bearings receive the oil film pressure they need to survive. The domino sequence never begins. While you have the timing cover off, inspect the cam phaser units directly. Look for evidence of vane seal wear inside the phaser housing, which will be apparent as scoring or discoloration. Inspect the CVTCS solenoid screens for debris accumulation, which indicates prior internal gallery leakage. Replace the timing chain tensioners with updated units and verify timing chain stretch is within specification before reassembly. Use a high-quality full synthetic oil meeting Nissan's API, SN, or later specification in the correct viscosity grade for your climate, and establish an oil change interval of 5,000 miles or less for any VQ engine used in performance applications. Oil condition directly determines gallery gasket longevity and bearing film pressure. Do not compromise on this. For every VQ owner watching this, the KuroCars community is where this knowledge lives and grows. KuroCars is a collective of serious enthusiasts, engine builders, and technical contributors who have collectively disassembled more VQ engines than any dealer service department. The forum threads documenting gallery gasket failures, the technical write-ups on EPS gasket installation procedures, the builder logs showing before and after oil pressure measurements following the repair are all there. This is not a community selling you something. This is a community that has already paid the price for this knowledge through destroyed engines and rebuilt them correctly the second time. If you own a 350Z, 370Z, G35, or G37 with a VQ35HR or VQ37VHR engine, join that conversation. Ask the questions. Read the teardown documentation. Share this information with every VQ owner you know, because the failure mode I described today is progressing silently in engines across the country right now. Nissan built an extraordinary engine platform in the VQ family. The performance potential is real. The community passion around these cars is real. But there is an engineering compromise buried inside every HR and VHR engine that the manufacturer has never publicly acknowledged in terms of directing owners toward proactive prevention. You now know what it is. You know exactly where it lives, what it does, and how to stop it before it takes your engine. The parts are cheap. The knowledge is now yours. The only question is whether you act before the symptom appears or after the repair bill arrives. Next video, I am going to show you something that will permanently change how you think about every oil you have ever put in a performance engine. There is a specific additive compound listed in a 1987 military specification document that major synthetic oil manufacturers formulated out of their products in the mid-90s after a legal settlement with an engine parts manufacturer. That compound reduces metal-to-metal wear under boundary lubrication conditions by a documented 63%. It still exists. You can buy it for $12. And the reason it disappeared from consumer products is a story that will make you genuinely furious. That is next. Do not miss it.